Hey students, this is lesson 721. In these lessons, we're going to learn how to understand and interpret situations mathematically and create inequalities to represent them. And we're going to learn how to apply methods for solving inequalities. And also how to represent them graphically. Okay? First thing I want you to think about is this think and discuss here. Look, check out the symbols. Make sure you know which way is greater than, which way is less than. And first thing here says, how is the meaning of 7 is less than x similar to or different from that of 7 is greater than x? Well, saying 7 is less than x, x means all numbers. So what we're saying is 7 is less than all these numbers. So the numbers would be like 8, 8.5, 9, etc. Any number that is actually 7.5. So this means really any number that is higher than 7 is a solution. And that's exactly what this means. Any number greater than 7 is a solution. So these are the same. All right? And we're going to be doing some things called compound inequalities, and that's what this is. And this is just combining two things. We are saying 7 is less than x, which we just saw from the previous example is exactly the same as saying x is greater than 7. And at the same time, x is less than 10. So in this one, we need to meet two inequalities. So we're really talking about numbers that are greater than 7, less than 10. So as an integer, that'd be a number like 8. As a decimal, that'd be a number like 9.9. But 10.1 would not work because 10.1 is not less than 10. So here's how you write this as two inequalities. And three values that work here, we just listed two of them there. You can think of one more to write in there. Okay. Sometimes another thing that students mess up when they're doing less than greater than, if I say which is greater, -8 or -6, sometimes students think that -8 is greater than -6. It's actually less than -6. So to help think about that, think about temperatures. Which is colder, 8 below or 6 below? And the colder the temperature, the lower it is. Okay? All right, let's look at this one. List 6 whole numbers that satisfy this inequality. N plus 1 is less than 11. Okay? One of those numbers could be, so we just need to be less than 11. So how about 0? Is 0 plus 1 less than 11? And 0 plus 1 is 1. And 1, that's true. And if it's true, that means it's a solution. So 0 is one possibility. Another possibility, and we can keep going up, like 1, 2, 3, so I'm doing 3 plus 1, that's 4, and that's less than 11. I can keep going right up until I get to 10. At 10, 10 plus 1 is actually equal to 11, so it's not less than 11. So that's where I'd have to end. So anything up to 9 is a whole number, or any negative number would also work. Okay? Now, number 2, we're going to try and write this statement. K is less than or equal to 14 and greater than 9. K is less than or equal to 14. Well, the less than sign is this. So K is less than or equal to 14. And, let's just write the word and for now. K is also greater than 9, so we're going to write K is greater than 9. Okay? Now, since this number is smaller than this, I can write this as a compound inequality. So this would actually shorten what I need to do by a little bit. And I can write K is greater than 9 is the same as saying 9 is less than K. So 9 is less than K. And K has to be less than or equal to 14. So I can put it all into 1. All right? And it says list all whole numbers for which the inequality is true. Go ahead and pause the video right now and go ahead and write those down. Here's the numbers you should have written down. 10 through 14 as whole numbers. Remember, though, that there are lots of decimal numbers that also would work, like 10.2 and so on. But it just asks you to list the whole numbers in that one. Okay? All right, I'm on the second page now. It says, consider the inequality 15 is less than or equal to m is less than or equal to 18. Write the inequality in words. So what we're going to say is all numbers, so to represent, m can represent any number, right? So we can say any number that is greater than or equal to 15 and less than or equal to 18. So that's how it looks like in words. Go ahead and it says list all the whole numbers for which this inequality is true. I'll pause while you do that. Are there any other numbers, not necessarily whole numbers, for which this inequality is true? If so, give some examples. So go ahead and write down 3 examples here. Pause it while you do that. Let's skip down here to number 7. We're looking for numbers whose absolute value, remember absolute value turns every number into a positive number. And you can pick 6 values, not necessarily whole numbers, that make this true. So remember, you could put any negative number in for R, and the absolute value would turn it into a positive number. So a number like negative 18 would work here, as with positive 18. And they don't necessarily have to be whole numbers, so something like negative 19.5 would also work, or positive 19.5. And then here, we want t to be greater than 0, so that means it's positive. And we want t squared to be less than or equal to 16. So, and the reason why they said that, if you could take any negative number like negative 10, and if you square that, that's 100. Negative 10 times negative 10 is positive 100. Well, there's no way that number is going to be less than or equal to 16. So we're looking for numbers that only square them, we get a value less than or equal to 16. And if you think about the square root of 16, that's 4. So we need numbers that are going to be less than or equal to 4, but greater than or equal to negative 4. So like negative 3 would work, or positive 3, things like that. This 3 squared is 9, and 9 is definitely less than or equal to 16. And but we can't use 3 because this thing says that t has to be. We can't use negative 3 because t has to be greater than 0. All right, let's try a situation with words and see if we can't put that into symbols. And I'm going to go to the next page, and we're going to do this truck problem here. It says the bed of Jose's trailer is 120 centimeters above the ground. Each layer of cartons he loads onto the trailer adds an additional 40 centimeters to the height. His loaded trailer must be able to pass under a footbridge with an underside that's 4 meters high. Write an expression for the height of the trailer when it holds n layers of carton. So the height starts at 120, you can see that, but then it adds 40 centimeters per additional load of cartons. So we're going to multiply 40 times the number of cartons, loads of cartons. Let's just call it X for loads of carton. And so that expression represents the height. Now remember, this height is in centimeters. Now, the trailer, to get under the bridge, has to be, the bridge is 4 meters high. 4 meters times 100 centimeters per meter is 400 centimeters high. Our height has to be less than that to get under the bridge. So, so our 120 plus 40x has to be less than, or, well, it can't equal, because equaling would actually hit the bridge. So we want to make sure we are less than 4 meters which is 400 centimeters. All right, we'll do some more of these in class. Go ahead and try a couple more on your own, and we'll talk about it next time we meet in class.